Right, colleagues, in our today's class, we have to start. We are going to revise the test which we wrote yesterday. I did manage to go through most of the people's tests, but I did not comment individually. Most of us, it looks we are getting there, but there are some few misconceptions which I will point out as we do the revision. But I would like to really appreciate Minenhle, Onfense, Matlatse, Kabelo, Lee, Charlotte, Busiso, Charlotte, Busisiwe, and Otembele for participating in the test. It shows that you are confident yourself. You also want to see how far are you getting with the chapters. That's a very good thing, colleagues. Keep it up. So as you are going to do the revision, we are going to mark. Please mark yourself accordingly. Then after the test, you send to the inbox how much out of 50 did you score. Don't be ashamed by your mark. I know we are still getting there. Remember, work, energy, and power is a term for next term, a topic for next term. So after our revision for today, next week, we are going to start Doppler effect, which is the second topic of physics for term 2. I think Monday, Tuesday, and another month will be done with it. Then we can go to chemistry, rest of reactions. So, as we are going to start, the first question was saying, a net force F accelerates two isolated objects, P and Q, from rests on a straight line for time t as shown on the diagram below. Object P experiences an acceleration of A, and object Q an acceleration of 2A. If the amount of work done by force F on P is W, what about the amount of work done on Q? So the idea was, because Q, the acceleration is 2A, remember, work done, our formula said work done is equals to F net delta X cos theta, work done by the net force. So because Q, the acceleration now is double, instead of MA, I've got 2 times M times A. So our best answer there was supposed to be letter number C, which is 2W. The work will double twice, because F net is no longer now MA, but it's now M times 2A. So the moment you double the acceleration, you double the work. So our answer was supposed to be C, 2W. You give yourself 2 marks for the first question. Right. Question number 2. Which one of the following forces is absent in an isolated system? Remember, in the exam, we always know an isolated system is a system where there are no external forces. So the question is, which one of the following is absent? Which one is absent, is not there in an isolated system? Electrostatic force, applied force, normal force, and the weight. What was our best answer for that option? Number 2 was supposed to be the applied force, which was letter number B. Remember, applied force is a non-conservative force. Friction is a non-conservative force. So it must be absent for the system to be isolated. Applied force must not be there, because it's a non-conservative force. Electrostatic force and the weight, they are conservative forces. So they must be there in an isolated system. Remember, normal force don't do any work. So we cannot talk about normal force. So our best answer was supposed to be B. You carry yourself 2 marks. Right, question number 3 was a diagram for time against work done. Time against work done So the question was saying the gradient of the graph represent what? Remember, in maths, in physics, gradient is change in y over change in x. What is on the y-axis? Work done. What is on the x-axis? Time. What is work done over time in physics? What is that thing, colleagues? Work done over time. What do you call that thing in physics? Work done over time is what? Which quantity is work done over time taken, colleagues?
Ma'am, I think it's power.
Is power. So the best answer for option number 3 was A. Work done over time taken, that is power. So the multiple choice was supposed to be 6 marks. 2, 4, 6. Work done over time is power. So option was supposed to be option number A. Then you get multiple choice 6 out of 6. Anyone with a question on the multiple choice question? Anyone which need clarity on the multiple choice question? Right. Let's go to number 2. Let's go to number 2. Structured question. A rock mass 1 kg is at rest on a rough horizontal surface as shown in the diagram below. When the rock is slightly pushed, it rolls at a velocity of 0.2 meters per second to the west. So this rock we can see on the diagram, it was on a rock there. This rock was 1.6 kg. Then it rose to come to point A, point B. The distance between the two was 0.5 meters. 0.5 meters. Now they are saying, the map is saying west, north, south, east. So they are saying this rock is 1.6 kg. A rock 1.6 kg is at rest on a rough horizontal surface as shown in the diagram below. When the rock is slightly pushed, it rolls at a velocity of 0.2 meters per second to the west. So it goes 0.2 meters per second to the west. The rock reaches point A, this point, with the same velocity 0.2 meters per second, and then moves down a rough 0.5 meters distance along slope AB. So from AB, 0.5 meters. But you are told the angle of inclination is 30 degrees. Draw a labeled free body diagram for the rock while it moves along the slope A to B. 3 marks. Remember, A to B is rough. Most of you get it very correct. I love that. I checked, most of you get it correct. 3 marks, 3 forces. So our slope is like this. Normal force is not straight. Normal force will slant. Something like this. It must be 90 degrees with the surface, remember? So we have our normal. Then most of you colleagues were showing the components, which is what was good. FG parallel. Some they say FG perpendicular. But if you don't want to show components, straight down W. Then there's a force which is opposing the motion, which is going this side. You call it friction. You can draw this diagram or can draw the one showing the components. I love the one showing the components though. But you all get total marks. FG parallel, straight with normally, FG perpendicular. How are we marking this one, colleagues? Your 3 marks, if you do the first diagram, it's 1, 2, 3. But please make sure that your normal is not straight. Your normal must slant. It must slant at an angle like this. It must slant. If you make it normal straight, then you are wrong. You mark yourself wrong. If you use this one for components, the two components, they carry 1 mark. Friction 1 mark. Normal 1 mark. So in total is 3 marks. Then you get your total marks 3 out of 3 for the free body diagram. Are we following, colleagues? Define a non-conservative force. Define a non-conservative force. How do we define that? A force or on which work done or for which work done in moving an object. For which work done in moving an object between 2 points. Between 2 points. You can say is dependent, or can say depend. It's still okay. Is dependent, or can say depends. Depend. Is dependent. In my case, or can say depends. Is dependent. Dependent of the path taken. Of the path taken. A force on which work done in moving an object between the 2 points is dependent of the path taken. And like I say, depend on the path taken. This was 2 or a 0. So the keywords which you must look there. Dependent must be there. Between 2 points must be there. And the work done. So you see, I've underlined almost everything. So if one of the underlined word is not there, if one of the underlined word is not there, then it is a 1 out of 2. If you have got 2 words which are not there, then it's either a 0 or it's either a 2. So you mark yourself either 0 out of 2 or you mark yourself 2 out of 2. Right. Our next question, colleagues. What was it saying? Give a reason why this is not a closed system. So they're asking you, do you know what is a closed system? Why this system is not a closed system? Why is it not a closed system? What do you need to mention there? You can say external forces are present. It's correct. You can say external forces are present. Or then I can say frictional force is present. What do you mark that one? External forces are present. It's not isolated because there is external forces. External forces are present. Please don't say the system moves freely. I just checked some of the others. They say the system is freely. No, it's not freely. But we look at it, there's the presence of external forces. Either I can mention that, or I can say frictional force. Frictional force is present. Frictional force is present. So it's not isolated. So any one of these reasons was carrying 1 mark. Any one of the 2 reasons. If you say the system is not moving freely, it's not correct. That's not isolated. We need you to mention external forces are present. Or you can say frictional forces is present. Then you get either got 1 mark there. Right. Next question. Calculate the frictional force experienced by the rock as it moves from A to B. As it moves from A to B. If the coefficient of frictional force between the rock and the surface is 0.12. Right. 1 mark was the formula. Which formula are we using? Fk is equals to mu kn. So if you have this formula, colleagues, you deserve 1 mark. You deserve 1 mark. Right. Then what is our mu? Our mu is given 0.12. Right. Remember, I saw most of you colleagues, that's what you missed now. Normally is not straight. So normally, if it is straight, normally is mg only. But because my normally is not straight, normally is mg cos theta. So most of you colleagues were leaving the cos theta. You only say m times g. Then you were making that correction wrong now. So which means our normally mass 1.6, our g 9.8. Then most of us, you forgot cos theta because normally is not straight. So which means what is cos? Cos the given angle, cos 30 degrees. So most of you colleagues, you are leaving cos 30 degrees, then you miss the next mark. Then you miss the next mark. So after I do it properly, you're getting your Fk as 1.63 newtons. Can we confirm the answer, colleagues, please? Let's see if we're following up. Mu is 0.12 times our mass 1.6 times our G 9.8 times cos 30. What answer are you getting, colleagues? What answer are we getting? Let's talk, then you can move.
1.63 newtons.
Yes, thank you, Lee. 1.63. So look at the marking point, colleagues. 1 mark is for the formula. 1 mark is, if you just say mg, mu mg, then unfortunately you don't get the next mark. Whatever underline until cos 30 to give you 1 mark. So if you miss the mark for number 2, definitely you miss the mark for number 3. So you get 1 out of 3. But if you got everything like there it is, you get 3 out of 3. Is there anyone with a question there, colleagues? So it's 3 marks on that. Somebody with a question? No. Site, are you saying something? Okay. All right, dear. Right. Let's look at our next question now. You gave your friction as 1.63. What are they saying in the next question? Use the energy principles to calculate the velocity of the rock at point B. Use the energy principles. That's why I say the moment you draw your free body diagram, you can identify the forces which are doing work. In our case, those we have showed the components, they are now at an advantage now. So when there is friction, we either use work net, change in EK, or you use work NC. You just choose what is easier for you. So let us use W net is equals to change in EK. So 1 mark is for the formula. W net is equals to change in EK. A common error which I see to most colleagues which I check their scripts. Guys, when you're talking about W net, most of you are talking about net force. You're putting forces as they are instead of putting W. Remember, W means work done by friction plus work done by FG parallel. These are the two forces which are doing work. 1/2 our mass final velocity minus initial velocity squared. So most of the colleagues you were adding F plus G parallel. You forgot you were talking about work. You forgot you were talking about work. And how do you calculate friction, by the way? Is friction, now we're doing what we call positive marking. If your friction was wrong on the top part, 1,63, if your answer was wrong, then we take your wrong answer as it is. You are very correct. Friction, distance 0,5, cos 180 for friction, cos 180 degrees. So if everything which is underlined is there, you give yourself 1 mark. If you have got a wrong answer from the previous question, colleagues, you also deserve that 1 mark because we are doing positive marking. The formula carries 1 mark. Right. Plus, how do we do the FG, work done by FG? Remember, FG parallel is the same as mg sine theta. M is the mass, G is the gravity, sine given angle, sine 30 degrees. This is FG parallel. Multiply by distance, 0.5. What is our cos for FG now? What is our cos, colleagues? Cos what? What is our cos? Cos what angle for FG? Cos what?
Cos 0.
Cos 0. Motion is going down. Gravity always goes down in this case. So cos 0. So if everything underlined is there, if everything underlined, then you deserve 1 mark. Before even simplify, you deserve 1 mark. It must be m times g times sine 30 times distance times cos 0. You deserve 1 mark in that. This is equal to, my board is finished, I'm continuing on the equal sign side. This is equal to 1 over 2. I have the mass 1.6. Which velocity am I looking for according to the question? Am I looking for final velocity or for initial velocity? The question says, can you calculate the velocity at point B? Is it the final velocity or the initial velocity, colleagues?
It's the final velocity.
Thank you. Thank you, Cabello. So final velocity squared. Remember, the system was at rest, so I say 0 squared. If everything which is underlined here is there, you deserve your 4th mark. Before you simplify, you already have 4 out of 5. Remember, I'm looking for velocity at B, so that's the final. The system was at rest, so initial is 0. So if everything is there like that is underlined, you deserve 1 mark. Then if you simplify now with your calculator, I was expecting 1.98. So if you get 1.97, I saw some they get 1.97. It's very correct, depending on your rounding off. But if you get 1.98 meters per second, then the last mark was for the answer. So you can get 1.97 or you get 1.98. The answer is very correct. Then you get 5 out of 5. Is there anyone with a question regarding number 2?
Yes, ma'am.
Yes, ma'am.
The statement below the diagram, it says the rock reaches point A with the same velocity of 0.2. So isn't it our initial velocity 0.2?
Oh, you are very right. Oh, it's just that the initial velocity is 0.2, right? Oh, the downslope, yes. The rock reaches point A with the same velocity of 0.2. Oh, so it's not 0. It was not at rest. You are very correct, ma'am. It's supposed to be 0.2 squared. But I understand, I think it comes with that one. It just 0.2 squared, you are very right, not 0. Because it did not start from rest. You are very correct. Thank you for that one. So the velocity initially is not 0, but 0.2 squared. Thank you for that, ma'am. So, but our answer was coming as 1.98 or 1.97. Depends with your calculator if you round off along the way. It's not the only approach which you can use, colleagues. You can use WNC. Those who know this one. WNC is equals to change in EK plus change in EP. We are still going to get the same answer. If you use the same approach, we are still going to use the same answer. 1,98. So, but normally the work net change in EK is very straightforward. But if you are comfortable with this one, your answer must also come the same answer. It's also accepted. It's very correct. Can we move to question number 3, colleagues? Is there anyone with a question? Can we move to question number 3? Right, question number 3. A 75 kg block is initially at rest. A 75 kg block is initially at rest on the ground. It is then lifted vertically upwards at a constant acceleration of 0.65 meters per second squared by using a light inextensible string. Refer the diagram below. Ignore the mass of the string, rotational effects, and air resistance. So they are saying this block was initially at rest, then it's lifted upwards 12 meters by a string, and it was moving with a constant acceleration 0.65 meters per second squared. 3.1. Can we name a non-conservative force acting on the block? 1 mark. Which force is non-conservative there? Which one do you identify as non-conservative force? Which force is non? Yes. Tension. Yes, Elena can say tension is very correct. We also accept applied force. Though it's not that good, but we also accept applied force. Because they said it was lifted up, it was pulled upwards. But the best answer is tension. But if you put applied force, we also accept it. We also mark it correct. But the best answer is tension. Because there's a string. So there's a force going up called tension. But if you mention applied force, you mark yourself correct. Yes, it's correct. But the best answer must be tension. 3.2. Can you draw a free body diagram for the block while it moves upwards? 2 marks, 2 forces. 2 marks, 2 forces. So the 2 marks which are there, we expect the obvious one. The force going down. What is the name of that force? Gravity, thank you. You can call it W, you can call it FG. The choice is yours. You can say weight, you can say FG. So it was 1 mark for tension, 1 mark for FG. Guys, in the exams, 2 marks, 2 forces. So if you put applied force, I saw one in the class there. I don't want to mention the name, but I saw one who put like this. I saw one who put like this. Then there was also applied force. F applied. Moment we have got 3 forces, colleagues, out of 2 marks, we mark all the 3 and we give you 1 out of 2. Because you put an additional force. So in the exam, when you say 2 marks, please, we mean 2 forces, 2 solid lines. 2 marks, 2 forces. Don't put 3 forces, please. 2 marks, 2 forces. Then you get your nice 2 out of 2. Tension and FG. So if you put F applied and FG, it's okay. But the best answer was tension. Right, the next question. What does it say? Calculate the work done on the block by the gravitational force when the block has reached a height of 12 meters, 3 marks. Right, because motion is along, along like this, colleagues, which means all these two forces are doing work. So, if I want work done by gravity, 1 mark is for the formula. Work done is equals to F delta X cos theta. You can write the general formula. You are very correct. Or you can write a specific formula. When I say specific formula, I mean a learner can say work done by FG or by W. The learner is writing a specific formula for W now. Then a learner will write MG because the learner knows FG is the same as MG. Delta X cos theta. Any one of these colleagues carry a mark. Either you give this formula or give this, you deserve 1 mark for the formula. You deserve 1 mark for the formula. Then, do I know my mass? Yes. What was the mass of the body? 75. Do I know my gravity? Yes. G is 9.8. Do I know the distance covered? It was 12. Cos what? That's the question. Cos what? Cos? Yes, you said cos what? Minete? Cos 180, colleagues. Remember, motion is going up. Gravity is going directly down. So it must be cos 180. Cos 180. Moment we see this statement here from there to there, you deserve a 2nd mark. The last mark was for the answer. Minus 8820J. Then you deserve the 3rd mark. You might have used another approach. Work done by W is change in EK plus change in EP. We still get the same answer. Remember, change in EK is 0 because it was at rest. But change in PEP, you use MGH. If you use this formula, W, work done by this one is equals to change in EP. You might have used this approach, change in EP. So which means change in EP, the height, remember, is MGH minus 0. Why 0? Because this object was on the ground. So your mass is 75. Your G is 9.8. Your height is what? Is 12. But remember, this was initial, finally, minus initial. Finally is, there we go, MGH. Minus initial, it was on the ground. So which means you're still going to get minus 8820. Whatever method you use, but your answer must come with a minus. So it was 1 mark for the formula, 1 mark for using cos 180 in this approach. If you use this approach, 1 mark is negative 25 times 9.8 times 12. Last mark is the answer. Then you get 3 out of 3. Is there anyone with a question regarding that, colleagues? Right, 3.4 states the work energy theorem. This one I always say that, colleagues, every exam we have this question. State the work energy theorem. I did see a lot of versions which were very correct. Some they were saying work done by a resultant force or a net force is equals the change in kinetic energy of the object. That was correct. Some they were saying net work done. I see about 3 versions, which was very correct. Net work done on an object. On an object. Net work done on an object is equal to the change in the object's kinetic energy. Object's kinetic energy. This was very correct, but please take note of the underlined words. Net object's kinetic energy and change. This one, unfortunate, it might give you a 0 or a 2, because if you miss 2 underlined words, it's a 0. If you miss 1, it's a 1 mark. Some they might say net work done by the net force. Net work done, or the work done by the net force. Work done by the net force. Work done by net force. This was very correct. Net force is equal to the change in object's kinetic energy. This was also very correct. This was also very correct. But please take note of the underlined words. If any underlined words is missing, then we deduct 1 mark. If it's in the wrong context, then it's a 0. So you check yourself context. If your underlined words are there, you give yourself 2 out of 2. If there's any one miss, let's suppose you just say net work done on an object is to the change in kinetic energy of the object, then the word equal is no longer there. It's not making sense. Say now it's wrong. It's 1 out of 2. But if you say the work done by force is equal to the change in object's kinetic energy, you don't mention the word net, so it's 1 out of 2. But if everything is there, it's 2 out of 2. Or if you are missing 2 words, it is 0 out of 2. Are we clear with the definition, colleagues? Right, last one, 3.5. Use the work energy theorem to calculate the speed of the block when it is at a height 12 meters. Use the work energy theorem. Use the work energy theorem. You cannot use any other thing, colleagues. So the first mark, the very first mark, is to put the formula for work energy theorem. W net is equals to change in EK. W net is equals to change in EK. The very first mark is for the formula that you know. So if you did not use work energy theorem, colleagues, unfortunately it's a 0 out of 5. If you use another formula which is not this one, then when you are marking, it's a 0 out of 5 because you are using the wrong concept. So please take note in the exam. If you say use work energy theorem, please use work energy theorem. Don't use equations of motion. So if you use another approach, unfortunately it's a 0. Right. If we check there, colleagues, a learner can now simplify this one. But remember, there's work done by tension plus work done by gravity. I don't have those two. So you come back now and say, what physics can I use now? I'll use work done by a net force. Remember, where there's work done by net, you can say which one is doing that? Work done by a net force. So I'll say work F net is equals to 1 over 2 m v final squared minus v initial squared. But remember, in the paper, you were given acceleration. That's why I'm going for this route, colleagues. You were told that acceleration is equal to 0.65. So you must now show us that F net is equal to MA. Unfortunately, there was no mark for that showing off. If you show it 0.75, the mass, and 75 the mass, multiply by 0.65. F net is equal to MA. F net is equal to MA, Newton's second law. There was no mark for that, but that's what approach which we are using. So our mass, 75. Our acceleration, 0.65. Multiply by delta x, we are doing work. Multiply by delta x, which is what? 12. Cos what, colleagues? Cos what? For net force, cos what? For net force, cos what? For net force, always cos 0, very correct. Net force, all the forces acting at a point, the angle will be 0 degrees. Net force will be equal to 0. So we have 1 over 2. Our mass, we are told, is 75. The question is saying, can you calculate the velocity or the speed of the block when it reaches a height of 12 meters? But you are told this one, it starts from rests. So which velocity do I know, colleagues? It initially starts from rests. Which velocity do I know?
The initial velocity, which is 0.
The initial velocity, which is 0. So I have got V final squared minus 0 squared, because initially 0. So when we're marking, how are we giving the 5 marks? I'll give you 2 approaches. I know some of you have used another approach. If we see 0.75 times 0.65 times 12, you deserve 1 mark in that part. Then if you just indicated cos 0, I don't know what to write there, but if the word cos 0 is there, you deserve another mark. Then if you manage to simplify V final unknown, V initially being 0, you deserve another mark. Then the last mark was for the answer after you simplify. The last mark was for the answer after you simplify. I was expecting an answer which is 3.95 meters per second. Meters per second. Then the last mark was the correct answer with the correct units. If your answer is 3.94, I did not get that one. 949 is okay. 949 is okay. Or 95. If you don't want to use this approach, Elena can use F net is equal to MA. Elena can use F net is equal to MA. And Elena will get tension. Okay, let me go this way. Because there are many ways of doing physics, colleagues. There's not only one way. But the very first answer must be work net is equal to change in EK, because we're using the work energy what? Theorem. So Elena can come and say, option number 2, F net is equal to MA. But remember, the system is going up. So Elena will say tension minus mg. M is 75. G is 9.8. Is equals to mass is 75. Acceleration we are given is 0.65. So Elena will get tension first. There are many ways of doing the problem. Elena will get tension first. And if you do your tension properly, the Elena will get 783.75 newtons. Then after I do that now, you go and use the formula work done, work net is cost change in EK. So you say work done by tension plus work done by Fg, you're still gonna come to the same answer. So Elena can use straight away F net is equals to MA, M times A, delta X equals 0. Or Elena can first of all calculate net force. Elena can first of all calculate net force and get tension now. After the Elena get tension, I wish to write it down. After the Elena get tension, let me write it on top here. Elena will use the approach now. W net is equals to change in EK. The Elena will come and say work done by tension plus work done by gravity. They are still doing the same answer. 1 over 2m v final squared minus v initial squared. Because the Elena has already got tension. 783,75 multiplied by distance, which was 12. Tension will be cos 0 because motion and tension same direction. Plus work done by gravity, I think we get it. Why do we stress ourselves? It was 8,820. Do you still remember that, colleagues? Is equals to 1 over 2 mass 75. Final velocity is what we are looking for. Initial is 0. So Elena can use this approach. We're still gonna get the same answer if you practice that. 3,95 meters per second. So how do we mark this? How do we mark this? First mark, remember, is the formula. First mark is the formula. W net is equals change in EK. Second mark is for you to get tension now, which is what we did down there, and get our tension is 7, comma. So this answer here will give you a mark. Then by saying cos 0, the cos 0 will give you a mark. Then the right hand side will give you a mark. The last mark is the answer. So still gonna come back to 5 out of 5. So you might have used another approach, colleagues, but as long as your answer is coming like this and the formula for work net is there, then you deserve 5 out of 5. Is there anyone with a question, colleagues? Lee, are you following up?
Yes, ma'am, I'm following.
Good. If you are lost, colleagues, don't be shy. Please raise up F1 and please say something if you are lost. I want us to do the last question now. So that one was the total for question number 3. So work energy is not difficult as long as you understand the concept. It's not difficult at all. Right, our last question was saying number 4. Question number 4. The diagram below shows a bullet, mass 20 grams, that is traveling horizontally at a velocity q. The bullet strikes the stationary block, 7 kg box, and becomes embedded on it. Embedded means they became one unit. The bullet and the box, they travel together on a 2 meter long rough horizontal surface xy before coming to a stop at point y. Use the work energy theorem to calculate the magnitude of the velocity of the bullet block system immediately after the bullet strikes the box. Given that the frictional force of the box and the surface is 10 newtons, use the work energy theorem. So 1 mark out of 4 is this one. W net change in EK. That is the first mark, colleagues. Use the work energy theorem. Then you know work energy theorem, you save 1 mark. If you use another approach, then unfortunately it's a 0. It must be strictly work energy theorem, please. If they say use, you must use that. Which forces are doing work? It's a rough surface and it's horizontal. So the only force doing work is friction. So we're going to have F diameter X cos theta is equals to 1 over 2. Remember, this way most of the colleagues, you lose the mark now. You did not combine the masses. It was supposed to be mass of the bullet plus mass of the small. It was a box and a bullet. Then velocity final squared minus velocity initial squared. So most of the colleagues, when I check your answers, you were missing on the mass. Most of you are using 1 mass, which was a problem. So we are told the friction is 10. Delta X distance was 2, covered. Friction we don't negotiate. It's always cos 180 degrees. 1 over 2. What was the total mass? Remember, in physics, mass must be in kgs. So you're told that the bullet has got 20 grams. So you're supposed to convert the grams to kgs. How do we convert grams to kgs, colleagues? We divide by what? Grams to kgs. We divide by what?
1,000, ma'am.
1,000, thank you. So because the mass of the bullet was in grams, you say 20 over 1,000. Then you get 0.02. So which means we're supposed to add there 20 over 1,000. Is it 0.02? Am I correct? 20 divided by 1,000. Yes, 0.02. Velocity final is what you are looking for. Am I correct? According to the question, they said calculate the velocity immediately after the collision. But they are saying velocity final, it comes to a stop. So I know the final velocity. This system comes to a stop. So which means the final velocity is what? 0. The initial is what they are looking for. Immediately after they collide, they are looking for the initial. But they said it comes to a stop. So which means final velocity is 0. So if you do our nice maths, let's simplify them. 1 over 2 multiplied by 7,02 multiplied by 0 minus V initial. Can you simplify for V initial, colleagues? Today you've been relaxing. Let's simplify for V initial. What are we getting? Let's quickly simplify for V initial. What are we getting? V initial, what are we getting, colleagues?
$2.39.
Thank you. Rounded off was correct answer 2.39 meters per second. But if you get 2.387, excellent, no problem. You round to 3 digits after the comma, it's 2.5. It's 2.5.
34.
It's 2.5. 2.39 or 2.387. Okay. Where are we putting our marks? 1 mark is for the formula, colleagues. 1 mark if you say 10 times 2 times cos 180. I don't know how do you put that one, but the moment you do that, you deserve 1 mark. The moment you do that, you deserve another 1 mark. Where do we put our third mark? The right hand side, if your mass is simplified and it's for sure 07,02, either you give your mark there or there is fine, you deserve 1 mark. The mass must be 7,02, simplified. The fourth mark was for the answer, whether 2,39 or 2,387, the last mark was for the answer. Is there anyone with a question regarding that? (4.2) Can we state the principle of conservation of linear momentum? I know this one was tricky. Some they stated the energy now. What is it saying? Total linear momentum. Total linear momentum of an isolated system. Isolated or a closed system remains constant. Remains constant. It remains constant. Where are my keywords? Remains constant, isolated, total. So if you miss one of the words underlined, it's a 1 out of 2. If you miss 2 of the underlined words, it's a 0 out of 2. So it's either a 2 out of 2 or you get a 0 out of 2. If you miss 1 word, you give yourself 1 mark. If you miss 2 words, unfortunately, it's a 0. Right, number 3rd question. Calculate the magnitude of the velocity q which the bullet strikes the box. So I did incorporate momentum. I know some of you forgot about momentum now, but we've done momentum. Sum of pi is equal to sum of pf. We are looking for velocity, so you apply momentum because we've done momentum, colleagues. Because we've done momentum. So 1 mark was for the formula. If you say m1 v1 initially plus m2 v2 initially, still okay. Then before collision, the two were separate. After collision, they were together. So you can say m1 v1 initial plus m2 v2 initial. m1 plus m2 multiplied by v final. This was the correct option B formula. But let's learn to write this one. It will never go wrong, colleagues. The summation one. So before collision, the bullet was alone. 0,02 VI. The box was stationary. 7 times 0. Remember the two masses. We've already combined them. 0.02. Then velocity, colleagues, we are going to do positive marking because the velocity is what you get above. If you did not get above the wrong answer, we are doing positive marking. So what do you mean by positive marking? If your answer in the top question was wrong, then you carry your wrong answer down. Where I underline there, you deserve 1 mark. This is called positive marking. You are carrying an answer from top question to here. So if your answer was wrong here and you put the wrong answer here, you deserve this 1 mark here. This whole side underlined deserve another mark. So if you have done positive marking, colleagues, you now use your calculator. You obviously are going to get a different answer from mine because your answer was wrong. But if you did this approach, you are getting 838,89 meters per second. That was the velocity of the bullet initially. 838,89. So if your answer is wrong here, colleagues, definitely you won't get my same answer. So which means your answer is going to be correct also if your answer here is wrong. if your positive marking is wrong. So the last mark was for the answer. So it was 1 formula, 2, 3, and 4. So if you carry a wrong answer here, you deserve also the answer. You get a mark for the answer with your wrong answer here. Anyone with a question there? Right. Number 4.4. The bullet experiences a force F when it strikes the box. How is the magnitude of the force experienced by the box compared to that one of the bullet? Greater than, less than F, or equal to F? What is our answer there? The bullet experiences a force when it hits the box. How do the force compare? What is our answer? What is our answer, colleagues? The force must be what? I was expecting equal to F. The force must be equal. Which law is this in physics, colleagues? Which law is this in physics? Which law is this in physics?
First law.
Newton's. When object A exerts a force on object B exerts an equal force but in the opposite direction. Which force is that? Which law is that?
Newton's third law.
Newton's third law, colleagues. So if the bullet hits the box with the force F, the box will also in different direction also a force F. So this was equal to, it's 1 mark. Then if you say we are doing negative marking, unfortunately, if you say less than, then which means your answer in the next question, oh, there was no negative marking, so you're going to be 5. There was no negative marking. So which means if you say Newton's third law, then you deserve your mark for 4.5. You deserve your mark for 4.5. If you say less than and say Newton's third law, we are marking them independent. We don't do negative marking. If this one is wrong, this one is right, you give yourself 1 mark. Our last question for the day, colleagues. Our last question for the day. Let's see how is it gonna go through. Our last question for the day. Question number 4.5. What was it saying? It says a 500 kg car accelerates on a smooth surface from 10 meters per second to 30 meters per second in 20 minutes. Use energy principles to calculate the power of the car. Which formula of power do you think we're gonna use here? Which formula of power do you think we're gonna work out for us, guys? Power is equal to what? I'm given velocities, colleagues. So which formula of energy can you come to your mind? Which formula of energy can we use here? Let's talk and finish. Which formula of energy can we use here? I'm given velocity, initial, final. Which formula of energy can we use, colleagues? My learners don't want to talk today. W net is equal to change in EK. Guys, do you know how this formula is used? It means you can either use the left-hand side or the right-hand side. This formula says you can use any of the two sides, colleagues. But let's use the right-hand side because I know velocities, colleagues. 1/2 m v final squared minus V initial squared. Do I know the mass in the problem? Yes. I'm told that the 500 kg. So I have the mass. Which velocity is final? Which one is initial, colleagues? Which one is final? Which one is initial? A car accelerates from 10 meters per second to 30 meters per second. Which one is final? Which one is initial, colleagues? Comrades, let's talk.
Initial is 10 meter.
And final is 30. You are very right. Final from 10 to 30. Final is 30. Initial is 10. Who can quickly give me the answer, colleagues? Who can quickly simplify the answer for me? Who can quickly simplify the answer for me? Let's have the answer, colleagues. Thank you so much. 200,000 J. Then I have got work now. I come and say power is equals to work done over time taken because I know time. Work done is 200,000. 200,000 J. Divide by time. Remember in physics time must be in seconds. So I've given 20 minutes. How do you convert 20 minutes to seconds, by the way? Times what? Times 60. Times 60, you are very correct. Minutes to second times 60. So if you do it your nice calculator, you must get something like 166,67. Or then I can have 667. That's fine. We can say 67J. Where do we allocate our 5 marks? Where do we allocate our 5 marks? Use the energy principles. There is issue of energy in our formula. There is issue of energy. Change in EK, energy is there. 1 mark for the use of the energy principle. You are using energy there. 1 mark for knowing that you are simplifying. 30 squared minus 10 squared. Everything underlined, unfortunate. 1 mark for the 200,000 J. You might use another formula with energy, but 200J comes out with 1 mark. There was no mark for formula again, because I've already awarded a mark for the formula energy. So the last mark, second last mark, was dividing the 2. Then the last mark is the correct answer. Then you get 5 out of 5. Is there anyone having a question on that one, colleagues? So if your formula don't have anything to do with energy, colleagues, unfortunately, you are not going to get any answer, any mark. I'm not going to give the formula for power because the question said use energy principles. Use energy principles. So you must apply a formula which contains energy. And we're given velocity final, velocity initially. You come to W net, change in EK. And the formula means you can calculate what is on the left or you can calculate what is on the right. So here we use what is on the right because I have info. Then you get your energy. We divide by time. Anyone with a question regarding this, colleagues? Silence means it looks like people are fine. So guys, as we are going to log off, please you mark yourself according to our discussion. Then you are going to send me your inbox, your mark out of 50 to see are we progressing. So if I see the marks out of 50, it can give me the option, say, as you are logging out, ready for Doppler or revision. You just indicate ready for Doppler. Doppler means the next topic, remember? Ready for Doppler, you can say ready for next topic, or you can indicate revision. If you see that, hey, your mark is too low, don't be ashamed. Please, I want all those who wrote, check, send your inbox answer, please. Send your inbox total mark. Because I've got about 13 people who participated in the test, which was very good. So as you indicate how much do you get, it's going to be easier for me to know, are we talking the same language? But now you indicate ready for next topic, or I can say revision. But it will depend on the marks which I get from those who did write the test. Colleagues, thank you so much for your night today. As we are going to meet next week, you are going to see I'll slightly change the time of meeting, either between 5 to 7 or 7 to 9, because I'll be traveling to another province where they have a different load shedding schedule. But I'll let you know in advance, either between 5 to 7 or between 7 to 9. I'll also indicate that as we plan for our next week, Monday and Tuesday lesson, colleagues. Have a good night. Bye-bye, colleagues.